Hello. Okay, now I can see that we are recording, that the microphone is working fine. So last time when we left, if you remember, we were seeing the powerful command that is called find. So we saw it for, if I remember, the last exercise that we were doing is we were searching file with a specific permission. So when you use a permission like that, it's exactly the permission that you want. When you use it with a /, you say any of the bits that I specify can be set. And when you specify it with a dash, all of the bits must be set. So for example, if let's come back to that. Here we created we have some files with different rights. Let's say that I want the file that have at the level of the user X, like this one, and at the level of the group, the W. And I want at least both of them. I want the X here and a W. Let me create another file. File 140.bin. And I'm going to put it that it will have all the rights. I'm going to put 777. Okay. Saying that I want X here on W. So I want all files that have both. So it will show me normally this file. It will also show me this file because this file have the X right for the user and the W right for the group. It will also show me this file, the one that I just created, no? So how can I do that? I can do find starting from the directory where I am. I'm looking for files that have the permission. So if I want the X at the level of the user, I need a 1 here. And if I want the right at the level of the group, I need a 2 here. So let me show you, no? That will be 1, that will be 2, and that will be 0. So this is the bit that I want at the level of the user. Read, write, execute. So I want the execute write at the level of the user. That will the bit at the level of the group. I want the write at the level of the group. And I don't mind the write at the level of the others. Okay, so let's see, we should have, oh, I want both, sorry. So I have to put a minus. So we should have 3 files. So let's see, the 136 is this one. It have the execute for the user and the W for the group. We have the 140, which have the execute at the level of the user and the W at the level of the group. And we have the 137, which have the execute at the level of the user and the W at the level of the group. So you can also do, for example, something like that, no? You want the user to have the execute right and the group to have the W right. You can just do that. It will show the same list. Or you can also say, I don't want to specify any specific right at the level of the other user. So it show me the same list. Okay. If I want all the files that have the set user ID set, we show how we can do that. So let me start from the root file system, and I just want the set user ID set, the bit set user ID set. So if you want the bit set user ID set, you have to do it like that, no? What does it mean, 4000? 4 is 100. 0 is 000, 0 is 000, 0 is 000, which means this bit is for the set user ID. I want it on. This bit is for the set group ID. I don't mind. This bit is for the sticky bit. I don't mind. I don't mind at the level of the user. I don't mind at the level of the group. I don't mind at the level of the others. So I will have all the files that have at least the set user ID set. So this file, we did it as you remember, but we can look at this file, for example, user bin su, switch user, and just verify that it have this bit in 1. So as you can see here, we have the set user ID in 1. No? Now, another way to do it is that I can write, for example, user must have the set user ID on. You see, user must have the set user ID on. It's another way to do it. So as you can see, it will give me the same list. For example, we have the user bin su. Let's verify, for example, with this one, the user bin group password file, which is an executable file, and allow me to change the password of the group. As you can see, it have this bit on, the set user ID on. So if I want the set group ID on, I can do, for example, 200. So let's verify that, for example, var games, BSD games have the set group ID on. Oh, it's a directory. Okay, so I want files. We have file, for example, this one. Xperi is a file. It's a binary file. User bin Xperi. And let's verify that it have it on. So as you can see it have it on. This bit on. So another way to get the same list is, for example, I can write, for example, the group ID have to be set. Okay, so G equal S, the group ID have to be set. So as you can see, we have this file again and all the other files that we have previously. Now, if you want both to be set, what can we do? If we want both to be set, if I do that, X is what? 110. Then we have 000, 000, 000, 000. So here I'm talking about the set UID and the set group ID. So if I do that, it will be at least one of the two. So it will give me the union of the set user ID set and the set group ID set. Now, if I want both, I have to put here a minus. It will give me the list that have both. So as you can see, we have this file and the file that we did 2 classes ago. So let's verify in this file that we have both. So as you can see, we have the set user ID and we have the set group ID. Both are set. And this is the file that we create like 2 weeks ago. It also have both sets. So let me just verify it. But it also has both. So you can see the set user ID is set and the set group ID is set. Now, if you want to do it another way, you can do, for example, user equal S and group equal S. It will show me the same list, which are 2 files, no? The one that we just saw and the one that we created 2 weeks ago. They appear in the list. You can also use, for example, UG. The syntax is very powerful. UG equal S. You are saying that both you want them in S. So as you can see, we have the same two files, this one and this one, no? We have them. Okay, now if I want the sticky bit on, what should I put? On just this, I just worried about the sticky bit. The sticky bit appears as a T. So I can do that, no? If I use an extended octal. So this, the first one is 001, then 000, then 000, then 000, no? So remember that in this octal, this controls the set user ID. Then we have this bit that controls the set group ID. And the last one controls the sticky bit. So you remember what is the function of the sticky bit? It's only work with directory. If I want to create a directory where user can create file, modify their own file, and remove their own file, I need to create a directory with the sticky bit that is on. So it will show me all the directory with the sticky bit that is on. So I want to go to this one. This is a very common directory in Unix, the temp directory, where temporary files are created. So we will see that it has the sticky bit on. Look at. The sticky bit is on. T for sticky bit is on. Which means that in this directory, user can create file, modify the file, remove the file, but they cannot modify the file of others or remove the file of others. This is what it means. So let's see how many users we have in this machine already. I think we already create some user. We have Betty, Eric, John, and Sally. So in one window, I'm going to enter like Betty. So in this moment, let's see who I am. ID, I am Eric. Okay, let's switch user to Betty. So in this window, I will be Betty. The password maybe is Betty, I don't remember. Yes. So if I ask my ID in this window, I am Betty. Let's have another window where we will be, for example, we have, let me see again the user that we have. We have John. So in this window, let's enter as John. So switch user, John. And it will ask me the password of John. I put John, so now if I type ID, I am John. So by default, when you enter, you are in your home directory. If I do print working directory, I am in my home directory, which is /home/John. And of course, Betty will be in /home/Betty. So as Betty, I'm going to go to the temporary directory and create a file. So for example, echo hello in a file that I'm going to call betty01.txt. I'm going to create a second file that is called, that have a content of by. So if I look at in this directory, I do have two files, the two files that I just created, and they belong to Betty, as you can see. So now as John, I'm going to go to the temporary directory, and I will have the possibility also to create my own file. Hello, let's put good morning in the first file. Let's go on 01.txt, and let's put good afternoon in the second file. Let me show you the listing of the file. So we have the two files of Betty and the two files of John. So as John, here I am John, no? ID, I am John. I'm going to try to remove a file of Betty. remove Betty 01. Do you want to remove it? Yes. And operation not permitted, as you can see. If I check, I could not modify, I could not remove the file of Betty. Now, if I try to edit it and modify it, I will not be able to do that. So look at, it's a, I'm trying to edit it with VI, and it's a read only. I'm going to try to force it. There is a warning, changing a read-only file. It's telling me that you are losing your time because you are making change and you will not be able to save them. Hello is my change. Okay. Let me try to save it. W for write. So look, it's a read-only option. I cannot do it. So there is a better option, which is W dash, but it will not allow me to write it. So let me go out, I lose my change. And if I look the content of the file of Betty, it still say hello. I was not able to change. So you are not able to change the file of others, but you can create your own file and delete your own file. For example, of course, I can modify my file. So for example, I am John here. I have a file that is called John1. Let me put good morning. How are you? So you can see that VI this time is not telling me you are in a read-only file. I'm going to save it and go out. And let me show the content, and it was modified. I have the how are you. So I can modify my own file and I can remove them if I want. I'm going to remove one of my files. Look at the listing, John01 does not exist. So this is that. Normally, most of the directory will have an owner, but if you want to make a directory for all the users, you can with the sticky bit. Okay, so if I want to find, let me go back here, and we did a command to find all the directory that have the sticky bit set. Another way to do it will be, for example, others is equal T. Okay, so as you can see, the temp directory did appear. Okay, is the sticky bit. Now, I am here, I am the root. I want to see all the file of the user John, starting from the root. So a way to do it, you can use the option -user. I want to see all the file of John. So John have a file in /etc, in /tmp, we just created. We created 2 and remove 1. So I will see it. We see which is the file John02. And John have file in his home directory. So where I am here, I am John. Let me go back to my home directory. Let's see what file we have. So we almost not have file. Let me create a file. Let me call it new John file. .txt, and I just put hello inside. That's okay. So I am asking a list of all the files that belong to John, starting from the root directory. So it will search all over. So look, let's see what we can see. So I have the file temp john02.txt that we created a few minutes ago, and I should see the other file. Here is the other file. Those file. Okay, we create another exercise in a special directory where some files belong to John. We can see them. We can see, for example, the new John file that I just created that belong to John. So you can search the file of a specific user. You can search the file of a specific group. So you have an option that is called group. And you can search a file that belongs to a group. Let me add a group. If I want to add a group, I'm going to use the command add group. Let me create a new group. And let's create this group, for example, group test. Add grp, add group. Test. Oh, dash G. Let me see. Let me see the add group command when you want to add a group. Add group. We put the group. I am here. I am roots. Group test. Please enter username matching the regular expression of your read in name regular expression. Oh, he didn't like the capital. Okay. So the groups on the user should not have capital by default. Okay, I create a new group in the machine. I'm going to create two files that belong to this group. So for example, in the directory of John, let me go to the directory of John. Home, John. Let me create a file. Let's call it this file. Let's call it, for example, today 01.txt. We are going to put ABC inside. And by default, who is the owner of this file that I just created? And who is the group that owns this file? So I'm the user root. So since I'm the user root, the file in this one belongs to the user root and the group root. So if you look, user root and group root. So I want to change the group and I want to put the group as group test. So let me do it. So we can use the command change group grp, and I want to put it in group test. If I look at the file now, it belongs to the user root and it is in the group test. So let me go, for example, to in the temp directory, and let me do a find starting in the root for file that belong to the group test. So there is only one file in this moment. It is in the directory home John, and it is called today01.txt. So look at it. It did find it. Home John today01.txt. Let me go in the home directory of, for example, Betty, and create another directory, another file like that. So with the command touch, let's call it today02.txt. And it will belong to the group root by default. I'm going to change the group. Change group. And I want it in a group that is called group test for the file today02.txt. So if I go back, for example, to my home directories as root is /root. And I search all the files that belong to this group. I should have the two files. So one that is in the directory home John, and the other one that is in the directory home Betty. And they are called today1 and today2. So let's do the command and look at. It did find a file that is called today01, which is in home John, and today02, which is in home Betty. So you can find by username, by group name. It's very powerful, no? Oh, Now, let's do a nice exercise. So I did create a directory, dir special, okay. Let's create some file with different date. So let me create a first file. Let's call it example01.txt. And we are going to create another one. So there is a powerful command to have information of a file, which is called stat for statistic on a file. So this is the result of running the command stat with this file. So it will tell me the size of the file. It will tell me the access, the permission that we have over the file. So here the permission is in octal, and here the permission is with symbol, no? So 644 is read write dash, read dash dash, read dash dash. So it will tell me who is the user of the file, the owner of the file is the root, and the file is in a group that is called Sally. And there is 4 time associated with a file. The birth time is when you created the file. The access time is the last time that you access the file. You make a read in the file. The modified file, the modified time is the last time that you modify the content of the file, for example. And the change time is the last time that you change, for example, the owner or the group or the permission. So the change time is associated with the permission, the owner, and the group. So of course, I just create this file. All the time are the same. There are 4 times, and all the times are the same. So if I want to change the access time, now it's not 2:59:40 anymore. If with the command date, I can have the date. No, it's 3:1:52. If I'm going to show the content of the file is called example01. With the cat command, I do a read inside. It will change the access time. So let me do it, and let's see the information of the file. So look at the birth time have not changed. The change time have not changed. The modified time have not changed. What have changed is the access time. The last time that a read operation was performing in the file, it was at 3 p.m. and 2 minutes and 13 seconds. Of course, if I do, for example, a command like more will also change because this will show me the content of the file. Will also change the access time. So I just did a more. Let's see what time it is in this moment. It is 2 minutes 57 seconds. So if I look at the information of the file, oh, the more didn't change it. Did I did the more? Yeah, I did more. The more did not change it. Ah. The cat do change it, the more doesn't change it. So strange. Let me see the less. The less didn't change it neither. But the cat do change it, no? As we see, cat, for example, example. And I look at the statistic. Oh, I know what is happening. It didn't change it again because the file now is buffered in RAM. So when I say show me the content, since it's buffered in RAM, it doesn't access the file in the file system because it's buffered in the RAM. Okay, what I can do, for example, is let me try to change the change time. So, for example, I can change the write on the file. Let me put 600 as write. 600 for the file example. And let me show the statistic. So you can see that these have been updated. Now it's 3 o'clock 4 minutes and 50 seconds. Let's verify it. 3 o'clock 5 minutes and 2 seconds, which is correct. So I modify the change time. And of course, if I edit the file, I will modify these 3 times. No, if I change the content of the file, let me change the content of the file. The file is called example. Let me put something inside. For example, EFG. And I come back and I show the statistic. So the access time will be modified, the modified time will be modified, and the change time will be modified. So as you can see, we did modify the change time, and we did modify the modified time. Now I know what is going here. There is a variable that we can set so that the access time every time that we access it change. By default, some file system will not change it because, oh no, what happened is that, sorry, what happened here is when I enter in VI, I enter at 3 o'clock 5 minutes 26 seconds. And when I exit and save, I did it at 3 o'clock 5 minutes and 31 seconds. This is what happened. So it's what we have 2 different times here. Because the read was done 3 o'clock 5 minutes and 20 seconds, and the write, when I save it, it was like 5 seconds after. So let's do it again. So here I just modify the access time because I read the file. So let's wait a little more second. Let's wait like 10. There is already 10 seconds that have passed. Like 20 seconds. Okay, I just saved the file. So if I look at the statistics, when I enter, it was 3 o'clock, 6 minutes, 56 seconds when I did a read to read the content of the file. When I save it, it was 3 o'clock, 7 minutes and 13 seconds. Okay, so we have time related to the file, and this is the day and time that I create the file. This will not change, no? It was a creation time. Okay, let me create another file. I'm going to call it example 2. So let me get a list of the 2 files. Yeah, I need a few minutes. So sometime your machine was hacked and you want to know what file we're accessing in the last hour. For example, the machine was hacked 20 minutes ago. So you want a list of files that were accessed in the last 16 minutes. You can have it. Or a list of files that were modified, for example, in the last 13 minutes or in the last day. Of course, if your system was hacked, it's good to know what files were modified. Because people, the hackers, many times, what it will do, it will put some file into your system so it can access your system again after that. It will put some file, some executable file that will open backdoors. So you don't realize that when the hacker comes back to your system. So of course, by putting backdoors, it's the person either create new file or modify file that already exists in the file system. No? Let me create another file. So we have file with different times. Okay. So the example. So look, we have two example file. I'm going to ask, for example, give me a list of file from the directory that the modification time in minutes is, for example, less than 3 minutes. So M for modification time, min in minutes. So it's less than 3 minutes. So look, he's telling me that those 3 files have been modified, there is less than 3 minutes. Now, look, the list is different. Example 1 does not appear because example 1 is a little older than the other 2 files. If I keep doing that, example 2 is going to disappear at one point from the list. Still there. Let me see the list. Yeah, this one, yeah, example 2 should disappear. Still there. $710 is $310, and this one was created at $3.7. So it have not disappeared because there is less than 3 minutes. Look, now we have just example 3, and if I keep going, in 2 minutes, it should not appear anymore because it will be, its modification will be older than 3 minutes. So if I want, look at, for example, the time that is now, and let's see the list of files. So if I want this file, it is in this moment 3:11, and it was created at 3:07, so 4 minutes ago. I can ask, give me all the files that were modified exactly 4 minutes ago. There is no one. Okay, 5 minutes ago. Okay, 5 minutes ago, these 2 files were modified. Look what I can say. I can say, give me the list of files that were modified. There is less than 6 minutes ago. So the modification was done within the last 6 minutes. Look at them. Within the last 5 minutes. So it's why I need several files. Let me create a new file. Touch example 4.txt. So look, give me the file that was created in the last minute. Example 4. In the last 2 minutes, no file. In the last 3 minutes, no file. In the last 4 minutes, example 3. You see? In the last 5 minutes, no file. In the last 6 minutes, example 1 and example 2. So you can say exactly that much minutes ago. So you put just an integer. For example, give me the list of files that were created 100 minutes ago, or let's put 60, 1 hour ago. So that will be with -16 within 1 hour. So all the files that we're modifying in the last hour. So of course, I create all these files in the last hour. In the last 5 minutes. Give me a list of files that were created. There is more than 1 hour. So for example, I know that the attack was done at a specific hours. So I can say, give me the list of files that was modifying between this range of minutes. For example, look at what I can write. They were modifying, for example, 1 hour ago or 2 hours ago, between 1 and 2 hours ago. I can do that. So you understand that will be between 1 hour ago and 2 hours ago. I know that the attack occurred like 1 hour and 20 minutes ago. So I can say, give me a list of files that were modified. There is more than 60 minutes and less than 120 minutes. So here there will be no file, no modification in minutes. There will be no file. Now, if I say more than 4 minutes ago and less than 10 minutes ago, I should have some. Yeah, you see, we do have. So you see the powerful tools that you have. You can ask about files that were modified in a range of minutes, because you have idea when the attack was done. So you want to target those files and investigate those files. So you can do that. Okay. The find command is very, very powerful. So I want to talk about user now in the system. There are two files that manage users. One file is the etc password. We will write it as passwd. And another file is the etc group. The other file is the etc shadow. So I am root here, and I'm going to show you the content of the etc password file. So first of all, look at the right on this file. The file belongs to root, and it is in the group of root. And root is the only user that can modify the file. The other user can see the content of the file, the user that belongs to the group root, and the other user can see the content of the file. So a normal user cannot modify the etc password file. Of course, this is the database of the user. So a normal user should not be able to add new user or to remove new user, or to remove existing user, sorry, or modify any information of a user. So we have this file, and we have another file, which is the etc shadow file. Look at this file. For example, if I am the user, here I'm the user, John. Can John see the content of the etc password? So look at the right of the etc password. This is the right. So can John see the content of the etc password, yes or no? So which right will be applied to John? The one of the user, the one of the group, or the one of others? Here I'm John. Which rights are going to be applied to me?
It'd be the others.
The others, correct. So the others can read the file. They cannot do anything else. So John should be able to read the file. So let's see if John can read the file. And it will be able, as we say. So look at the content. John was able to see the content of the file. This is the database of the user. Now, John cannot modify the file. So let me try to modify the file. Let me try to change the content of the file and put inside AAA, permission denied. You see? Okay. What about the etc shadows? What can John do over the etc shadow? What are the rights that will be applied to John? This right, no? John have no right on the etc shadow. So it cannot see the content of the etc shadows, for example. Let me try to see the content of the etc shadow. Permission denied. I have no right. Let me try to change it. Of course, if I cannot read it, Normally, I will not be able to change it neither. Permission denied. Okay, so let's see this file on the different field that we have inside. So let's start with the etc path. I'm root, and I'm going to show you the content. So this is a comma separated value file where we have 7 fields, and the separator is a column. So let me show my user. Let me show you the information of my user. So look at, for each user in the system, you will have one line. So the first field will be the username, the login. So my login is Eric. The second field is an X for the majority of the user. This is the password. So the password used to be stored in this file. And they decided at one point to remove the password from this file and to put the password of the user in the etc shadow file. So X here means that the password is in the etc shadow file. It is not there. This is the second field. What is the third field according to you? It's an integer. 1000 here is the user ID. As if I ask, what is the user ID of Eric? Let me see who I am here. Betty. Betty have a user ID of 1003. So let's see, Betty have a user ID of 1003. Eric have a user ID of 1000. The next field is what? It's also an integer, and it is what? The default group, the primary group. When I log into the system, I will be in this group. So a user can belong to several groups. But when you log into the system, you will be in a default group, in a primary group. So my primary group is group 1000, which is a group that is also called Eric, as myself. Normally, I'm the only user in the group 1000. I'm the only user in my group. Okay, then we have the fifth field. The fifth field is called the GECOS. G-E-C-O-S. The GECOS stands for General Comprehensive Operating System. So the GECOS is information about the user. Normally, we put some information, comma, other information, comma, other information, comma, other information. So the first information that we store is the first name and last name. Then we put a comma. We can put, for example, the office of this employee. Then we put a comma. We can put the phone number of the employee. Information like that. So you decide what information you want to store for each user. So you can put the home office, the office, the home telephone, the office telephone. For example, the office number of the employee, and you can define more if you want. So this is the fifth field. Then field number 6 is the home directory of the user. My home directory is within /home/Eric. Then the last field, which is the 7th field, is my default shell. You can change it. By default, I will use bash. But we have several shells. For example, we have boon shell, TC shell, K shell, C shell, a lot of shell. So my shell is bash when I log into. Let me create a user. So most of the people, when they create a user, they will use the add user command. And they will specify the logging. Let's create, for example, Bill Clinton, a user for Bill Clinton. So let's say that its user ID or its login will be Bill. Then this command is going to guide me through the process of the creation of the user. So before I create it, look at the last user ID that was used was 1003. So Bill will be created with 1004. And there will be a group that will be created with ID 1004 also. Okay? So let's try to create Bill. So user add Bill. I wanted to use add user. So user. Okay. Let's use add user, which is add user Bill. So now we have a difference because I did create a user Bill before, so it didn't go to 1003. So there is a user that is creating a user Bill. It is creating a group also. So that will be the home directory. It's asking me for a password of Bill. Let me put Bill. And retype the password. Let me put Bill again. The full name, Bill. It's like that, or there is a P? There is a P, no?
Well, the first, it's CLIN.
CLIN, PTON. That?
There's no P.
TON?
Yes.
Okay, thank you. So this is the full name, the first name and the last name. So the office number, let's say that it works in air all 777. So it's easy to remember. The work phone number, let's put 256 782. Let's put 7777 also. Or 7776. Or 66. Okay. Home phone number, let's put 256 8888. Other information, let's put does not apply. Is this information is correct? Let's put yes. So let's go to this file. See that we have a user that is called Bill now. Look at. We have a user that is called Bill. The password is not in the file. The password is in the etc shadow. That's the user ID. Oh, the user ID is 1004. The group ID, the default group is 1005. I create a group. I just create a group. So the group that I create is 1004. So we have the GCOS information. So look at the first name, the last name, comma, the office, comma, the office number, comma, the phone number in the office, comma, the phone number at home, comma, additional information. This is the home directory of Bill Clinton, and this is the shell that it will use when it will log. So we have 7 fields for each user. Okay? Let me now show you the etc shadows. The etc shadow, we will have the password of the user. So let's see the etc shadow of Bill. So here we have one line for Bill. So it's the same format. It's a comma separated value file where the separation is done with a colon. This is the password. So this is Bill. But the password is encrypted with a hash algorithm. So you cannot recognize that it is Bill. It's not stored as Bill, of course, because if you store it as Bill and somebody hack the file, the person will know the password of somebody. Now, if I give you this string, it will take you a long time to brute force it normally, unless you use very easy password. You should not use easy password, like password of short length, because they are easy to break. So you have a practice with John the hacker. I don't remember in which lab it is. You have not done it, no? The practice with John the hacker? Maybe it's in lab 4. John the hacker, John the Ripper, sorry, is a software that will allow you to try to crack easy password. So password with a small length. So if your password is 1 character long, 2 character long, 3 character long, John the Ripper will discover your password in a few seconds. So you have to put a password that is long enough. They recommend at least 8 characters. So another thing that is important when you choose your password is that you should use uppercase character, lowercase character, uppercase letter, lowercase letter, digit, and special characters. Special character like /, time, plus, divide, minus, dot, dollar, arrobas. You should put some special character in your password. Okay, so this is the password. Then we have other information that I will skip for now. So let me show you that if I install John the Ripper, the password of Bill is Bill in this moment. The password of Betty is Betty, which is very bad. There is also something that you should take into account when you create your password. Don't put information about your login in your password. If my login is Bill, don't put Bill in your password. If my login is Eric, don't put Eric, because all this software will try to do combination of your login with other character to see if your password is include your login. In the past, many people will put as password, for example, their login and their birth date, birth year. So if they were born in 2000 and they are called Bill, they will put Bill 2000, which is very bad because it's very easy to guess. So don't put your login into your password, and don't put neither your GCOS information into your password. For example, my office is IRL 234. If I put this, it is already in the GCOS. So if I put this information into my password, it will very easy to crack my password. So you should not put information that people know about you. For example, the name of your boyfriend or girlfriend. If you have a pet, the name of your pet, don't put that in your password. Because if somebody wants to do damage to you and they know information about you, they will put this information in a dictionary and they will do a dictionary attack. So you should not use word of the common words. For example, word of city like Jacksonville, Miami, you should not put that in your password. You should not put words like, for example, table, car, floor, because if somebody use a dictionary attack is I'm taking word from the dictionary and I add around this word some character and I try to see if it's work. It's a brute force attack where I do use words that are in a dictionary. So before we go through John the Ripper, let's see more information about user. So you can create a user manually. Let me create a user manually. So to do that, I am root here. I have to do several things. So I'm going to edit the etc password file. I'm going to go to the last line and make a copy of the last line. And here I'm going to create a new user. So let's say that I want to create a user for somebody that is called Bruno. So I put Bruno here. The ID of Bruno will be 1005. The group of Bruno will be 1006. I have to create it. Bruno Encanto. Let's call it. This is a cartoon of Walt Disney in this moment. Okay, I don't want to put his office number, his phone number at the office, his phone number at home, and other information. So its home directory will be home Bruno. And the bash that it will use by default will be bash. That's fine. So I already have this line for Bruno. Now I need to go to the etc shadow and duplicate, for example, the line of Bill and create a line for Bruno. So look, if I don't change the password, Bruno will have the same password as Bill, which is Bill in this moment. Okay, I'm almost done. I need to create a home directory for Bruno. What will be the command? So I create one line in the etc password and one line in the etc shadow. What will be the command to create a home directory for Bruno? So it will be make dir /home/Bruno. I create a home directory of Bruno. Now, what should I do with this home directory? This home directory in this moment belongs to whom? Belong to the root. It should not belong to the root. It should belong to the user Bruno and the group Bruno. If you look at, for example, the home directory of Eric, it belongs to Eric and the group Eric. If you look at the home directory of Bill, it belongs to the user Bill and the group Bill. So I have to do the same thing with the home directory of Bruno. So how can I change that? So change owner Bruno, the home directory of Bruno. So now if I look, it belongs to Bruno, but it's still in the group root. So I need to change. Oh, we need to create a group Bruno. We have not created a group Bruno. I did that a little fast. So there are two files to manage groups. One is called the etc group, and one is called the etc G shadow. G for group shadow. So let me show you the content of the etc group. It's also a comma separated value file. So look, for example, when I create Bill, it adds one line in this file. So this file will have 4 fields. Each line is a record with 4 fields. So the group name and the separator is a colon. Then the group password is an X. which means that it is not in this file. It is in the file etc gshadow. Then the group ID. And then the list of users that belong to the group as a second group, not as a primary group. So let me edit this file and create a group for Bruno. Let me copy the last group, which is Bill, and I'm going to create a group that is called Bruno, and his group ID will be 1006. There is also a etc G shadow for group shadow. So let me go here. So it's also have 4 fields. So I just create a copy of the record of Bill to create a record of Bruno. So this is to say that it doesn't have password. So X means the password is not in this file, and the exclamation means it doesn't have password. So the group Bruno doesn't have password. So now that I create the group Bruno, I can go back to my question of I need to change this group from root to Bruno. So the command is change grp. You put the new group that you want, and you specify which directory or which file you want to change. So look at, now we have the home directory of Bruno, which is /home/Bruno, belong to the user Bruno and to the group Bruno. So the last file that I need to do is to specify a password for Bruno. So I can use the command password, passwd, Bruno. And it will ask me to type a password for Bruno and to repeat it. So password for Bruno, let me put Bruno, which is a bad thing. Retype the password, let me put Bruno. So now Bruno is ready to go. We created a user manually. So to do that, as you see, I modify 4 files. I create a home directory, and I change the right on the home directory. So now let's log as Bruno. So let me do the command switch user dash Bruno. It will ask you what is your password. We put Bruno. Let me put Bruno. And look, I am connected as a new user, Bruno. So look at, my user ID is 1005, the one that we specify. My primary group is 1006, and it's called Bruno. And this is my list of group. It includes the primary group and all the secondary groups. So in this moment, Bruno just belongs to the group Bruno. But we can change that. For example, I can put Bruno in the group Eric. I can put Bruno in the group. I can create, we create a group today. What was the name of this group that we create? A test group test. And it is, to know it, I can check in the file etc group. It is there, group test. We create this group test. So let me put Eric in this group. So there is a command that is called user modify -a for add -G add in the group test the user Bruno. So the effect, here I am Bruno. If I ask, I don't see that I'm in the group for now, because when I log in, I was not a member of this group. Let me go out and enter again. I'm going to enter again. So I put my password, Bruno, and then I do ID. And as you see now, my primary group is Bruno, but I belong to two groups. I belong, of course, to my primary group, and I belong to the group that is called group test. So in this moment, if I create a file, the file will belong to the user Bruno and the group Bruno, because my primary group is the group Bruno. Let me create a file with touch file01.txt. And let's see this file. As you can see, it belongs to the user Bruno, group Bruno. Now, I can say that I want to change my primary group. Because I belong to two groups, I can say, oh, I want my primary group to be this group test. If you want to change, if Bruno wants to change his primary group, it have to use the command new group and put the name of the group, the new primary group that he wants. I want to be in the group that is called group test. I want my primary group to be group test. Now, if I type the command ID, look at, I still belong to the group Bruno and the group test, but my primary group now is group test. So if I create a file, look at the difference. Previously, when I create the file 501, it belonged to the user Bruno, group Bruno. Now that I create file 02, it belongs to the user Bruno, group test. So you might ask, what is the result of creating different groups? So let's see that. That's a good question. Let's see why we need different groups. Let's say that we have a command, and we want this command to be available only to a group of users. So only the user that belong to this group should be able to execute it. So what I'm going to do is, let me create a small file here, a C file, that will say hello and show my user ID and my username. So let me create, let's call it hello.c. So I'm going to include stdio.h. So I'm going to call a function that is called getUserID to get my user ID. So man getUserID. So to use this function, I need to include these two header files. So let me copy them and paste them here. Okay, I have the two header file. I'm going to do my main function. So int main. I'm going to return 0 if everything works well. So I want to show my user ID. So if I want to show my user ID, I need to call the function getUserID. This is the header of the function. Let me put it here and let's do the modification. So I need a variable, for example, that I'm going to call user ID. And in this variable, I am going to store a call to the function getUserID. And here I'm going to print hello, your user ID is, and I'm going to show an integer in decimal, and I'm going to show my user ID, UID. Okay, for now, let's do this program. It's very easy, no? It's a program that will show when I run it, hello, your user ID is, and it will show my user ID. Let me save this program, compile it, and call the executable hello. Oh, there is thing that I did wrong here. Get UID, printf, hello, your user ID is. Warning. Missing terminator character. Oh, I see. I put backslash, but I forgot the n. Backslash n for new character here. Okay, let's compile that again. Okay, it does work. So I am root here. If I execute this command, it say hello, your user ID is 0. The root have a user ID of 0. Let me copy this program in a temporary directory. Of course, here, for example, I am Bruno. The user ID of Bruno is 1005. So if I execute this file, we say, hello, your user ID is 1005. You see, hello, your user ID is 1005. Here I am Betty. The user ID of Betty is 1003. So if I execute this file, hello, your user ID is 1003. Okay, that's fine. Let's put also the username. To get the username, there's a function that is called get password UID. Okay. To use this function, I need to include these two files. I think the first one is already included, but not the second one. So let me pass this here. Yeah, the first one was already included. It is there. But the second one is not included. I'm going to include it. So I'm going to call this function. The function that I want to call is this one, get password user ID. This function is very powerful, and it will bring me the 7th field of the etc password. So let me define what I need to define here. I need to define a structure that is called password, a structure of type password, and let me call the variable pw. And here I'm going to do pw, and I'm going to call this function. So when I call this function, it will return the password. I will store it in pw, and I need to specify the user ID. I got the user ID in this line, and I use it. So look at the structure password have the name, the password, the user ID, the group ID, the gcos information, the home directory, and the default shell. It have the 7. I'm just interested in the password name. So for example, I'm going to put here, hello, your username, sorry, the username, no. Your username is, it's a string, so %s. And here I'm going to put password pw underscore name. Okay, because they say it is called like that, pw underscore name. Okay, let me compile that. No problem. Let me copy it. Okay, let me run it now with the modification as Bruno. So it says, hello, your user ID is 1005, your username is Bruno. If I run it as Betty, here I'm Betty. Hello, your user ID is 1003, and your username is Betty. So, look at what will happen if I do that. 500. Let me show you this file again. Who can execute the file hello now with this right?
The user.
The user, the owner of the file. Okay, because the X is only for the owner. So only the owner of the file will be able to execute it. Who is the owner of the file? The root user. So the root user can execute it, but it will be the only user that can execute it. So let me execute it. So look at it say, hello, your user ID is 0 and your username is root. Let me try to do it as Betty. She will not have the right. Permission denied. Let me try to do it as Bruno. He will not have the right. Permission denied. Now, what will happen if I do this change on this file? Change group Bruno and change mode. Let me put 510. We don't need 5. It can be 110. Look at the right of the file now. Who can execute the file? This is the right of the file. Who can execute the file? So we have X for the owner. Who is the owner? The root. So the root can execute it. We have X for the group. The group is Bruno. Who belongs to this group? Only the user Bruno. So out of the root, the user Bruno will be able to execute it. So let's try to execute it as the root. As you can see, I can execute it as the root. Now let's try to execute it as Bruno. I should be able. I was able. Let's try to execute it as Betty. She will not be able. Permission denied. Okay? Now what can I do if I want Bruno and Betty be able to execute it? But for example, Eric is not able, Bill is not able. So I just, out of the root, I just want 2 users to be able to execute this executable file. I want Bruno and Betty. What can I do? So I can create a specific group of people that will have rights on this file. So let me create a specific group. So with add group, I'm going to create a new group. Let's call it the hello group. Hello. Okay, I create a new group that is called group hello. Now I'm going to put Betty and Bruno in this group. So user modification -A to add, -G, I'm going to add them in a group that is called group hello. And who I'm going to add? I'm going to add Betty and I'm going to add Bruno. So now if I ask the ID of Bruno, Bruno will belong to the group hello, as you can see. If I ask the ID of Betty, she will belong to the group hello. So now what should I do over this file to allow only the root user to execute it and the user that belong to the group hello? In this moment, there are only 2 users in the group hello. What should I do to this file? Here we are discussing permissions, what we allow each user to do in the system. I allow them to execute the hello file, or I don't allow them to execute the hello file. Of course, the hello file is an example. It has to be a command that is important. For example, shut down the files, shut down the system. Only a few users should do that. Maybe you have a printer, a color printer, and you want only a few users to use the color printer. So you can define a group, put the people in this group, the people that have access to the color printer, and only these people will be able to execute the command to print in the color printer. So this is what we need. We need to create groups. So what should I do to this executable file to allow only the root to execute it, which is the owner, and the user that are in the group hello, which is Bruno and Betty. What should I do? So here, I'm going to change the group to the group hello. So I'm going to use the command change group hello for this file, tmp hello. Let's verify it. So look at, the file belongs to the user root, so the user root should be able to execute it. So let me try to execute it as a root. There is no way that root have restriction. Root don't have restriction in a Linux machine. So as you can see, root can execute it. Now, who else can execute it? We have X here. All the users that belong to the group hello. We have two users in the group hello, Betty and Bruno. They should be able to execute it. So when Betty entered the log in the system, she was not in the group Bruno. She was not in the group, group hello. So if she tried to execute it, it still say permission denied. Let me exit. The next time that she will enter, you see that she belongs to the group hello. So she will be able to execute this command. As you can see, she is able. The same thing happened with Bruno. If you look at Bruno, when it entered, it was not part of the group hello. So it have to exit, enter again. As Bruno. I look my ID. I do belong to the group hello, as you can see here. So I can execute the command. Now, if I look the user Eric and all the other users, they should not be able to execute this command. So let me see who I am. Here I'm John, for example. John will not have the right. So if I try to execute this file, the hello file, permission denied. All the other users that are in the system will not have the rights. So group is a way to create a group of users and specify the right for this group of users. For example, you may have a web server and you may have 4 people that manage the web server. So you create a group for the web service. You put these 4 people into the group of the web service. And all the executable that they need to execute, you change them so that they can execute them. But only those people that manage the web server, these 4 people, will be allowed to make modification on the web server. For example, to shut down the web server, to put the web server up, to change, for example, the content that the web server is providing to the rest of the world. So it's why we create groups. We create groups to assign the same permission to all the members of the groups. It's a way to make the administration easier. And a user can belong to several groups. So for example, you may have somebody that work on the web server, and let's say that also work, for example, in with human resources. So human resources have their own software. So you create a group for human resources. You put all the people in the group of human resources. And this person that work in both, on the side of the web server and human resources, you put this person in both groups. So this person will be able to manage the web service and manage the software that the people of human resources are using. Okay? Okay, so that was a small introduction on how we create groups, why we create groups, and how we create users. Okay, I'm going to stop here for today. In the next class, we are going to see some practice of a password. Why it's important to choose a good password. And why it's important that you don't use the same password everywhere. Some people do that because it's much easier to memorize. But the problem is when the hacker know that many people do that. So the problem is when they hack one of your password or one of your account, if you use the same password everywhere, the hacker will go to your bank account. It will go to your university account, the one that you have in JSU, to your mail. So it's why you should not use the same password in all the accounts that you have. You should make them different. They should be easy for you to remember, but they should be very complex to guess. Easy for me to remember, but very complex to guess. So I am far away from what we call a brute force attack. Okay, I see you in 2 days. Thank you.